at a number 1 for dependent and independent variables? Everybody can do that? Yeah? I'm ordering pizza for the class.
Really?
No. I am ordering pizza for the class. What are the 2 variables that would concern me? How much pizza I need and, pardon me? How many students are coming, right? Which is dependent? Pizza, because the more students that are here, the more pizza I need. If it was a sunny Friday in June, I could get away with 1 large pizza because none of you will be here. If it was a pouring, yucky, rainy Friday in November, I would have to order enough pizza for all 30 of you. Right? So everyone is good with that? Okay. What about the next one? Can you tell if a relation is a function? Now this one's a little tricky because there's 2 ways to do it. On a graph, how do you know if it's a function? I know you know, Wong. How do you know on a graph if it's a function? The line test. Everywhere I draw a vertical line, it only hits once. But what if you don't have a graph? Then what must you check? Yeah, the inputs and outputs, right? Right? If 2 independent variables give you the same dependent variable, it's not a function. It's a relation. If there are 2 inputs or more, so greater than 2 inputs, that give you the same output, it's a relation. Are all functions relations? Yes. Are all relations functions? No. I can determine if a relation is linear. Again, on a graph, super easy. How do you know on a graph? If it makes a straight line, it's linear. Easy. What if you're not on a graph? What would the next one be if this were linear? 5 and 12. Right? Okay. 2 things in the next one, discrete and continuous, and explain why. Is everybody at a 1 at a 2 or a 3 there? Okay, we got some 1s there. Which part of it? Discrete, continuous, or the explanation? Both? All right. If it is discrete, then you cannot, for the most part, the best way I can explain it, if you don't understand it, is if you cannot have fractional inputs, then you have discrete data. Go back to my pizza question. If I need 2 slices of pizza per person, and a large pizza has 8 slices, then how many people can I feed with a large pizza? 4, right? Now, if 1 more person comes in, I need to order how many more slices of pizza? 2. Can half a person come in? No. So if I was graphing the pizza, 1, 2, 3, I can only go up by person. There can never be an input of half a person. So I could never order 5 slices. Understand? I need 2, 4, 6, 8. I'm not going to ever need 5. So I'm never going to have an input here that will give me an output. The pizza line would be there, 2, 4, 6. If I draw this line, that makes that point, which can't exist. Understand? If the point can exist, then it's continuous. Domain and range. Anybody still at a 1 on domain and range? Remember, this is, again, there's two parts to this. There's recognizing the domain and range and being able to write it down. Can everybody find the domain and range? Where is domain? The independent variable. Where's the range? Y. Dependent variable, because I can turn a graph sideways, can't I? So don't get trapped in that axis thing. That's why I talk more about IV and DV in this unit. Everybody cool? If you're going to write it down, that IV and DV, or that domain and range, could I write it with the arrows? Could I write number less than or equal to x less than or equal to number if I graphed that? Yes or no? Yes. Why? Because it's continuous data. And all of these x's are part of it, because every one of those x's hits the line. What if it was this? Now what's my domain look like? Single numbers. 1, 2, 3, and so on. Same for range. Everybody knows open and close dot? Okay. I can describe a situation for a graph. You can tell me the story of a graph. 1, 2, or 3. Any ones? Remember, are you ever getting marked on your prose? If you do not know what that means, I will say it again in simpler language. Are you ever being marked on the quality of your story? No, this is not English class. Aight? Tell me what's happening. Can everybody draw a graph if they're given a scenario? We all understand what flat lines mean. We all understand that if there's time as an independent variable, can the graph ever go to the left? No. Can the graph ever go vertically? Vertically. No, why not? Because you cannot stop time. All right? If I am drawing a displacement graph, can the graph go both up and down? Yes. If I'm drawing a distance graph, can it go up and down? No. Right, distance over time. Thank you. I jump out of a plane. What will the graph of my altitude versus time be? Will that line be going down or up from 0 time? Down. I have jumped out of the plane. So at 0 time, I am up in the air. Okay? As time goes on, I fall towards the ground. Wait for it. Change it around. No. No. Don't guess. I am in a submarine. The submarine goes under the water. What does the graph look like? It would go up because my depth is increasing. Unless I was graphing something like this and I said sea level was 0. Then the graph would go down. Good. And finally, function notation with algebra and a graph. That's what we did yesterday. With both of them, you can do it with algebra and with the graph. Everybody's at least a 2 there? No? Which one? Algebra, graph, or both? What is the... How are you going to fill in this chart? Great. Where? YX. X is the input. So I put in some numbers. 1, 2, 3. What are the Y's? 2, 3, 4. Everybody good? Okay. What if X was 76? What's Y? 77. What if Y was 802? What would X be? Why? Because I'd put 802 in there. It would be X plus 1. I'd minus 1 minus 1. 801 would equal X. Do you understand that? Great. In function notation, the only difference is we write f of x instead of y. So this line right here would be the f of 1. 1x has become 1, so that x becomes 1. So the f of 1 becomes 2. That is my output. That's how function notation works. Got it? On a graph, they're just x's and y's. If I were to graph this, when x is 1, y is 2. When x is 2, y is 3. When x is 3, y is 4. So, if I asked you, what is... So this line is going down 2, down 1 and over 1, right? Down 1 and over 1. So the line would look like this, yes? If I wanted the f of 0, that's where x is 0, right? So I go to 0 and I check. There it is. It's 1. If I wanted the f, if the f of x equaled 2, that's an output. So I go up to 2 and I find the x value, which is 1. Good? All right, everybody should be ready. I recorded this